You all know how beautiful the sky of our home planet Earth can be. Sometimes blue, sometimes with sparse white clouds, and sometimes covered in darkish thunderclouds. Hello everyone. Have you ever wondered what the sky might look like on other celestial bodies in our solar system? If yes, then you are lucky. This is our channel, and now you will know about everything. Let's go! Mercury. Mercury has particularly no atmosphere, so the sky here always looks black, day and night. Another major difference of Mercury's sky is the huge size of the sun. Since Mercury is very close to our luminary, it hangs in its sky like a giant fireball. Its diameter is more than twice the size of what it looks like from the Earth. Venus shines really bright in the Mercury sky, mostly because we only get to see its night side from the Earth, and the day side is visible from Mercury. The Earth and the Moon are also visible as bright stars. Unfortunately, it is very difficult to study Mercury, and so far not a single probe sent to this very first planet from the Sun succeeded to land on its surface. The photographs of the Mercury sky we have are taken from low orbit at best. Venus. The atmosphere of Venus is incredibly dense and has very thick clouds. Because of this, the sun is almost indistinguishable in its daytime sky, and the stars are not visible in the night sky. The overall lighting is also very limited here. Even during the day, the illumination here is roughly equal to earthly twilight. There are no photographs of the Venusian sky yet. Not a single decent vehicle worked on its surface for over 2 hours, and space probes exclusively photographed the surface due to their descent angle. However, based on our knowledge of its atmosphere's composition, sunlight passing through clouds of sulfuric acid should give it an orange color with a green tint. Moon. Just like Mercury, the Moon has no atmosphere, so the sky is always black here. However, according to the photographs taken by lunar rovers and astronauts, the stars are not visible during the lunar day. The sun shines too bright. The most beautiful landmark of the lunar sky is, of course, the Earth. Its apparent size in the sky is 4 times that of the sun. Since the Moon is pinned by tidal lock, the Earth in its sky always stays approximately in the same place and is not visible from the far side of the satellite. Just like we get phases of the Moon looking at it from the Earth, the phases of the Earth are visible from the Moon. Earth phases are exactly opposite to the lunar ones. For example, when on the Earth we see a new moon, on the Moon it's full Earth at this time. Mars. We have many photos of the Martian sky. Almost all rovers and probes, including the famous Curiosity, made those one way or another. However, the spacecraft camera sees the sky a bit differently than how the human eye sees it, and man has not set foot on Mars yet. The atmosphere of Mars is very thin, but at the same time, it is quite dusty. There are a lot of iron oxide dust particles in it, which give the sky a very specific color. By itself, the sky on the red planet is pink or yellow-brown. The sun appears blue, as does the sky around it. 2 satellites of Mars, Phobos and Deimos, are very small, but nevertheless, they are clearly visible from the surface and look brighter than all the planets. The brightest planets in the Martian sky are Venus and Jupiter. Jupiter. At the moment, mankind does not have photographs of Jupiter's sky taken from inside the atmosphere of the 5th planet yet, but we know enough about it to have an idea of what this sky could actually look like. In the upper layers of Jupiter's atmosphere, the sky will be blue, but somewhat dimmer than the Earth's. This is due to the fact that the fifth planet receives much less sunlight than the Earth. The deeper, the more the sun will be shaded by clouds of a wide color variety, mostly bluish, brown, and red. The satellites of Jupiter will be clearly visible in the sky, especially the largest ones, Io, Europa, Ganymede, and Callisto. Io, as the largest and brightest among them, will be the most prominent since it is the closest. However, even Io is dimmer than the full moon in the Earth's sky. And among the 4 Galilean satellites, only Callisto is capable of reaching what we call a full phase. This is because the other 3 moons are very close to the planet and rotate in the plane of the equator, constantly falling into Jupiter's shadow. All planets of our galaxy but Neptune are visible in the Jupiterian sky, with Saturn and Venus looking the brightest among the rest. Saturn and Titan. Cassini photographs show that the sky in Saturn's upper atmosphere is blue. In deeper layers, it gradually turns yellow. The famous rings of the 6th planet are clearly visible everywhere except its immediate equator, due to the fact that the plane of their rotation aligns with the equator of Saturn, and the rings are in fact quite thin. There are a lot of moons in the sky of Saturn, the brightest ones being Titan, Rhea, Dione, Enceladus, Tethys, and Mimas. Their apparent size is larger than the size of the Sun seen from Saturn, so they can cause solar eclipses. Other satellites are smaller and dimmer, but they are still looking brighter in the sky of the 6th planet than the distant stars. We should also mention the famous Titan, the satellite of Saturn. On all other moons, the sky is not exactly intriguing us. It's black, with the satellite's native planet hanging at one point in the sky, bold and bright. But Titan is a different deal, due to the fact it's the only satellite in the solar system endowed with a powerful atmosphere. Titan's atmosphere is very dense and consists mainly of methane and nitrogen. Sky color depends on altitude. At high altitude it looks mostly blue, at medium altitude it is shiny yellow, and from the surface it appears to be orange-red. Because of the thick clouds, Saturn is almost impossible to see on the surface of Titan, and the Sun seems to be just a bright speck. It is never brighter here than on Earth at dusk. Uranus. The sky of the 7th planet is blue. While known planetary rings are present, you won't see them. Even at high altitudes and equatorial latitudes, those are too thin and dim to be visible. An observer on Uranus can see all the planets in the solar system with their bare eyes, but Mercury will often fade out and disappear from view. The brightest among them will still be Venus, but Jupiter will have a brightness somewhat close to it. The Sun will look like a small disk. Its angular size will be only 2 minutes, while in the terrestrial sky, it is between 31 and 32 minutes. As with other giant planets with many satellites, solar eclipses should occur quite often on Uranus. As many as 5 moons of this planet will have sufficient apparent size in its sky to eclipse the Sun. These are Titania, Oberon, Umbriel, Ariel, and Miranda. An interesting feature of Uranus is the tilt of its rotational axis, which is about 98 degrees. It seems to be rolling on its side and slightly upside down. Because of this, on most of the planet's surface, except for equatorial latitudes, days and nights last for a half of the local year. The satellites of Uranus rotate in the equatorial plane, and due to the peculiarities of the planet's axial rotation, they are in the first or third quarter for most of the year. That is, only half of the disk ever gets visible. Neptune and trans-Neptunian celestial bodies. The Neptunian sky is blue, just like the one of Uranus. The sun will not be a disk on it, it will be a point in the sky with a size of only 1 minute. Although quite a bright one, 1,000 times brighter than the full moon in the Earth's sky. Triton, Neptune's largest moon, will look quite large, but somewhat dim due to the limited amount of light it gets. Among the viewable planets, Jupiter will be the brightest, with Venus being a bit dimmer. Earth, Uranus and Saturn will be rather dim, while Mercury and Mars will not be visible at all. The farther it is from the Sun, the dimmer it gets, following stellar logic. In the sky of Pluto, the Sun is still brighter than the full moon on Earth, but it appears very tiny. And some particular bodies, like Eris or similar, won't get any sun at all, staying in the eternal night. And that's where we will end today's little tour of other planet skies. Thank you for watching, friends. We hope you like it. If you did, please subscribe to our channel, like our episode, and don't forget to share it on your socials. It helps us make even better releases for you. And now, I say goodbye to you for a while. See you soon, my dears, and bye-bye.